Hi, welcome to another lecture of JS Yatra. In this particular lecture, we are going to develop the flatten function. The level of this question is medium, so without wasting any time, let's get started. That develop a flatten function that generates a fresh array by recursively concatenating all elements from subarray into a single level. What I mean by that is that let's suppose you have a flatten functions that accepts the array, and the job of this flatten function is to bring the nesting of this particular array to a single level. So in the example 1, you can see that 1 2 3 4 is already a single level array, so it doesn't has to do anything, just returns 1 2 3 as it is. What if we have 3 as a nested array? You can see that in the above example only 1 2 are normal items and 3 is an array itself. So what we are having currently over here is an array within the array, and if we call flatten function over this, this particular function is going to again give us the same result, that is 1 2 3. So this function brings the level of the nesting to the single level. Currently this particular example is having a nesting value of 2, but after the flatten function the nesting value becomes 1. Okay, by nesting value I mean the nesting level only. So let us check the another example. In this you can see that we are having two array elements inside the array and both are nested. So again the nesting level is 2 over here, and if I bring out the flatten function over here, it is going to give 1 2 3 4 5 as the output. So then we have another example where you can see that we are having an array which is containing 1, then another array which is containing 2, then inside 2 again there is an array containing 3, then another array containing 4, and another array containing 5. And when we call the flatten function over this particular example, this brings us to again 1 2 3 4 and 5. So in this particular example we are going to experience various type of approaches that we need that we can take to solve this particular question, and you are going to obviously learn new things with each lecture. So yeah, let us begin with coding. And first we can utilize the obvious JavaScript inbuilt flatten function. Let me tell you what this is. Flatten JavaScript. So array.prototype.flat, the flat method creates a new array with all the subarray elements concatenated to a recursively up to a specified depth. So if you can see in this particular example, if I run this, so if I run array.flat over here, you can see that it nested it to a single level. And again, if I call it without any arguments, it did flattening up to level 1 only. But if I just write infinity, then whatever be the nesting it has, it flattens the array to the single level. So what we can do over here is we can just use this flat utility function over here with us. The parameter is obviously going to be the array, so I am calling it args, or the arr must be fine over here, array, and I just need to do return array.flat infinity, and let's just clear the consoles and let me save this. You can see that this is working just fine for us. This is one-liner solution that you can use, although you are using a lot exactly the inbuilt solution for this question, and the interviewer might object you on using the array.flat method. Instead, he wants you to write the logics and the core edge cases, write the loops, and to iterate each value. So this is one approach. We'll be commenting this out so that you can refer it later. But coming to the approach, another approach over here, what we are going to use. So let me clear out. Okay. So another approach is to iterate over each element and fetch the item and check if it is array or not. If it is an array, then do some logic, and if it is not an array, just directly push the values. So it might sound a lot of thing right now, but once I write the code, it might get really very simple for you. Okay. So in this iterative approach, what we are going to do is we are going to take the first item of the array, and then we are going to check if this value is a array or if it's just a very normal item. If it is not an array, then we'll push this item into a placeholder, and if this is an array, then we will spread out the array and we will put that value in the starting again, and again we'll repeat the same process. The process is that to fetch the firstmost element from the array, to get it out, check again if it is array or not. If it is not an array, then you push it to a placeholder. Otherwise, if it is an array, then spread it out and again put that value what is you have received again back into the first place, and again you repeat the process. And this is going to be really very simple technique. This might sound a lot of stuff right now, but once I write the code, it may become all clear to you. So what we are going to do is, first of all, I talked about that placeholder. So we are going to create a const array equals to an empty placeholder. And what we are going to do is, since we do not want to mutate the actual array passed, all of this operation we are going to perform on a duplicate array. So we are going to create a duplicate array. So copy array, we spread it out and we created a shallow copy over here. And once this is done, what I'll be doing is I'll be basically looping over this copy array. So while since we are fetching or like extracting a element from the first index, we are actually modifying the copy array length. So as the time goes on, as the loop progresses, the elements present inside the copy array will get reduced and eventually the length will become 0. So on that note only, we are just going to check that while copy array dot length is truthful, it is not 0, then perform this operation. Okay. And so we'll be taking out the first item of the array, and to fetch the first item, the array shift JavaScript is going to become very handy. So the shift method removes the first element from the array and returns that removed element. It is very simple. This actually mutates the array. So if we are having this example over here, so you are having 1 2 3 and you are having first element as array.shift, array1.shift, and when you call this array1, you can see that 1 was removed, and in the first element you had the actual value 1 over here. So this first thing mutates the array and it also returns the extracted array item as well. So shift is a perfect candidate in this case, and what I'm going to do is I'm going to name it as const first item equals to copy array dot shift. Okay, this is going to give us the first item, and we just have to check that if this is an array or not. The best way to check if the item is array or not is to first of all invoke the array class, array dot is array, and you pass the item. So if this becomes true, then if it is an array, else it is not an array. So if it is not an array, we already know what we have to do. We just have to do array dot push first item. If this is an array, then what we have to do is, for example, this particular part. So if this is an array, okay, 1 2 3 is an array, and if I perform a spread operator on this, what is going to happen? So let me tell you how the spread operator is working if you are still confused on that part. So let me just, okay, we are having it over here. Let me get rid of all this thing. Okay, and if I just write, okay, if I just write dot 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 array1, you can see that you are getting 1 2 3. If I just write array, you get it from in form of array. But if I want to spread out the array like this, so you can see that you are getting individual item. Okay, 1 2 3 are no longer in the array, they are individual items over here. so they are not no longer part of the array. This is what I wanted to tell you. And if for by any chance this 3 is an array, you can see that 1 2 and you will get 3 as a separate array item. So at this place, when we are fetching the first item and I am seeing that okay, this is an array, all I want to do is I want to push the extracted part, the spreaded part of that array as the first element again. What I mean by that is, let's say we don't have 3 over here. Instead, I had one like this. So at the first place, when I'm looping over it, I am getting the first element. So array 1 is removed from the original array. Okay, this is copy. Okay, this is copy array. All right. And the first element is 1 over here. Now, by chance, I got to know that okay, this is an array. What I need to do is I need to first of all spread it. So after spreading, this would actually become 1. Okay, just 1. And I will push this 1 back at the first index again. So it becomes 1 2 3 again. And then again I am fetching the first element. Now in this part I am getting 1. So 1 is no longer an array, it is an normal number or a string whatsoever. It is a normal number over here. So I will push this item directly into the placeholder variable. This is what we are going to do. So I think you are clear with this approach now. What we have to do is we are having array.isArray first item, and all we need to do is push the spreaded part as the first item again. So how can we push certain item at the beginning? So there is a function for it called as array unshift. Shift and unshift are opposite things. So unshift method adds a specific element to the beginning of the array. Okay, this is what you wanted. So if I say array.unshift 4 5, this will give us 4 5 like this. And this is what I wanted to explain you over here. So for example, let it 4 5 be an array. So I want to push like 4 and 5 at the beginning. So if I just push array like this, so 4 5 will be pushed as an array item. But if I just spread this array item over here like this, then 4 and 5 will be presented as an individual array item, not an array. Okay, so this is the major advantage with unshift. So what we have to do is we just have to perform copy array dot unshift and first item dot like this. And let us clear the console and see if it is working. Okay, we haven't returned the array over here, so return array. Let me clear this out and save it. And again you can see that it is working just fine. So this was the iterative approach. The first one over here, this first one was using flat method, and the next one over here was using the iterative method. Okay, so unshift and shift, and this was the case. So let us just comment this out again, and let me write it that using iterative approach. All right, so this was the iterative approach. And in this iterative approach only, we can actually minimize the code complexity as well. By code complexity, don't get into time and space complexity, just that you can see a lot of work is being done over here, right? We are doing shift, then we are checking array, then unshift, then we are pushing as well, and we are creating another array item. So already there is a lot of work happening in this particular function, and as a developer I tend to minimize the lot of work in a single function. So how can we optimize this? So we can optimize it like this. So let me explain you how. Okay, so here is the improved iterative approach. So let me write the code for it first, and then I'll be able to explain that thing much better. So it would be like while array.sum array.is array, and what we'll do is we'll just make it like array equals to okay dot concat, and I'm spreading out it as a normal array. Yes, and have to return the array. Let us clear this and see if it is working. Yes, this is working fine. So let me tell you what we did. First of all, I didn't wanted lot of thing to happen. That is why I converted this thing into a 4-line code. Uh, Precisely, it is just three. We have only one return statement, so it is a 3-line code over here. And this was a massive like a code refactor that we did just now. And let me explain it to you what is happening. So I have already talked about the utility function array.sum. Let us open about it on MDN again. And over here, let us recall what it was doing. So the sum method tests whether at least one element in the array passes the test implemented by the provided function. So there is an array, there is a sum function, and inside the sum function you pass the function definition. Function definition contains the logic to test a particular item of the array. This is what we discussed. So what if I just change this thing to like array dot is array. So this is also a function definition as well, which returns true if the item supplied is an array. It returns false if it is not an array. So if I try to run this thing over here, it is going to give me false. Obviously, there is no item in this that is an array. But what if I just update it like this and I run, and there was some error. 1 second. And this turns out to be true again because there was at least one item that was an array. So array.sum is doing exactly the same thing. So inside this array, if there is any array item, then this particular thing is going to be true. And what we are actually doing once this become true is that we are first of all spreading out to one level. So we are flattening the array to one level, and then we are concatenating the output with the empty array. So if you're not aware about concatenation in JavaScript array, then let me explain it with the help of MDN example. And over here it says that the concat method is used to merge two or more arrays. This method does not change the existing array, but it returns a new array. Okay, this is acceptable. So over here we are having two arrays A, B, C and D, E, F. And you can see that we are calling array1.concat array2, and the output is stored in array3. And you can see that it turns out to be a single array containing both the items from array1 and array2. This is pretty much acceptable and this is okay. But what if I just tweak this thing like this? I have an empty array, and for example you assume that we are having this particular thing over here as ABCD, and if I just remove this thing as an array, so we are concatenating three items to an empty array, and let us see what the output is. The output is pretty simple, it is ABC. Why? Because the concatenation function can accept n number of values. Okay, so we can pass n number of values. So let us roll back the example again, and we are having an array. If I directly concat array with array like this, what would happen? You can see that it just concatenated the array item and there is actually no change. So this was ABC was already a array of nesting level 1. After concatenation, the final result is pretty much same. Again, ABC is concatenated at level 1 only. So we didn't made any difference. But what if I just spread this array out over here like this? And you can see that still it is giving us array of ABC, pretty much no change. But once I update the variable b as an array, and run it, you can see that it is still giving me the same level of nesting. This is not true with the case where we remove the spread operator. You can see that if we remove the spread operator over here, it is just concatenating these two array as it is without flattening the array by one level. Okay, so what we are actually hoping over here is that when we are performing any concatenation while this particular condition is true, which means that if there is any item in the array which is having a type of array, while this is true, then it already makes sense to gradually flatten the array, flatten the level of the array by one step. This is what we are actually doing. So this is pretty much the same I have explained in the previous two slides. Over here is the same, that while there is some array item in the array, what you already do is you just flatten down the array by one level and you update the array variable with it and repeat the same process again until there is no array item present inside the whole array. Once this while loop is completed, you just return the array. And trust me, this is a highly advanced code, and this is also a highly code optimized code. And once you write this type of code in interviews, trust me, the interviewer is going to be highly impressed with the code you have just written. All right, so this was the improved iterative approach. Okay, now we will jump to the recursive approach with array.reduced, and this is also a really great way of solving this flatten function. All right, so now we are going with the recursive approach with array.reduce. So if you are not familiar with array.reduce, reduce in JavaScript, then I can give you a quick introduction. And let's come over here. So array.prototype.reduce. So this is a definition, and if I just go by the definitions, then you might get confused, but let me just read it out for you, the main part, and once we have done it, I am going to explain it with the examples. So the reduce method executes the user supplied a callback function on each element of the array in order, passing in the return value from the calculation on the preceding element. The final result of running the reducer across all the elements is a single value. The first time the callback is run, there is no return value from the previous calculation. If supplied, an initial value may be used in its place. Otherwise, array element at index 0 is used as an initial value. So let us come to this particular example over here, and let's say I initially want to add or sum up all the values of the array over here. So what he is doing in this example is that he is having a reduce, and this is our callback function. It is accepting two parameters, which is a accumulator and a current value. Since we have supplied the initial value with 0, then it is taking like initial value is 0, and there is an accumulator and there is a current value. So accumulator has a initial value of 0 right now, and the current value is 1, and accumulator plus current value is what? 0 plus 1, 1, and this value is returned for each element, for each iteration. So when this 0 plus 1, 1 is returned, now accumulator actually becomes 1. Earlier it was 0. Now the current value is 2. 1 plus 2 becomes 3. 3 is returned over here in the accumulator. Accumulator has 3. Now the current value changes to 3 over here. 3 plus 3 gives us 6. 6 is in the accumulator. Now current value is 4. 6 plus 4 is 10. And it is returned in the accumulator. Now since there is no element to traverse in the array, now whatever was the last value of the accumulator, that is returned over here. Okay, this is pretty much simple. And if you don't supply the initial value over here, the only thing changes is that accumulator is having 1 and the current value is 2. Okay, this is the only change. So 1 plus 2 becomes 3 and so on. So this was the array.reduce method. And over here also we are going to implement something like this. All we want is that initial value must be an empty array that can store all the flattened array items as we traverse over the whole array. So let me tell you what I am planning right now. Since reduce method returns over here. So what is the return value? The value that results from running a reducer callbacks to completion over the entire array. Okay, so it is returning a value after the complete iteration. So this is what I want as well. So I'll call it return array dot reduce. Okay, and there is a callback function, and we also supply the initial value. Okay, we can come back to the initial example here, and if I do undo, you can see that we were having an initial value over here. So reduce is accepting two parameters. One is the function and another is the initial value. So I pass the function, and the initial value is going to be an empty array right now. And in the user supplied function, I am going to have an accumulator. I'll call it as ACC, and a current value via CRR. Okay, since we have supplied initial value, then accumulator is having empty array, and current value is for example, if you are running this, then this is going to be this particular whole array right now. Okay, this is having one. So in this in the accumulator we are having one, then we'll be having another array and so on. So currently we are having in the accumulator as one. So what I need to do is very simple, that I need to return something. Okay, I need to return something over here, and we have already seen with the concatenation function that it doesn't modify the original array, instead it returns a new array. So this is something we can utilize because it is returning something. So we can say it like accumulator dot concat. Okay, we are concatenating something, and we are concatenating what will be depending upon whether the item is array or whether the item is not an array. So if I just say array dot is array, if the current element is array, okay, then recursively call this flatten function. Let me increase the space for us. Recursively call this flatten function with current. Otherwise, all we have to do is we just have to return the current value. Okay, because it is not an array. And this might just work. Let me clear this out and save this. And this is working perfectly fine. I know you might be a little confused because many a times understanding the reduce function is not that easy. But trust me, you need to master this reduce function, because this is heavily used in production projects, and it has many use cases. So let me explain this approach again to you. We discussed what this array.reduce is doing. This is taking two arguments. One is the user supplied callback function that will be executed for every array item. So every array item, I mean that if we are calling it for 1 2 3, then it will run 3 times. This particular function will run 3 times, one for 1, for 2, then 3. Okay, then there is a initial value. Okay, so initial value is like when you are starting off with 1, there has to be some start. Okay, there has to be some start before 1 as well, and I supplied over here as an empty array. So this is an empty array for the beginning, and it will collect all the items that we have traversed so far. Now I start I start traversing the array item. Let us take example of 1 2 3. Okay, 1 2 and array of 3. So accumulator is empty array, current value is 1. Then we are having acc.concat. Okay, acc.concat is nothing, just we have already seen in previous example that what happens if the concatenation happens to an empty array. Okay, so this is nothing, just like this dot concat, like this, and we are passing that if the current element, okay, if the current element is an array, then recursively call it. Otherwise, just pass the current item only. So if I just say accumulator.concat 1 for this particular example over here, then this turns out to be array of 1. And since acc.concat is returning an array, so for the next iteration we are having array of 1 in the accumulator, and the current value is 2. Now since it is 2 over here, what will happen? It will call like 1 dot concat, and over here it will call 2. Okay, then this will become array of 1 and 2. Okay, now for the next iteration, this would be in the accumulator, and again it would be called with concat, and this time we are having 3 as an array item, so we will call the flatten function again. There is again we have again started a separate function called flatten, and it is accepting array of 3 as the item. Okay, then we are again reducing array dot reduce this, and in this cycle there is again an empty initial value. Then we are passing the concat, and this time we are iterating over this single array item. Okay, so this time we will just get 3 out of it because we are iterating over array element. Okay, please note that it will not take array of 3 as it is, it will just take the 3, because array of 3 is supplied as an argument after the recursive call, and we are iterating over each array item, so we are having 3 separately over here. And since 3 is not an array, this time it would be like this empty array dot concat 3, which would result out array of 3, just like this. Okay, once this is done to us, right, like this, so this would be returned from this particular recursive call, and we are going to place 3 over here like this. Okay, now 1 2 concatenated with array of 3 would give us 1 2 and 3. This is as simple as this. Okay, so this was about the reduce approach that we used just now, and this is a recursive approach. The downside of recursive approach is that if the stack limit is breached, then it will cause an overflow in the application if we are going beyond the memory. The interviewer might ask that, okay, without creating any extra space, can you solve it? Yeah, that is also possible. That only possible by updating the supplied array only. So in this part we are not updating the supplied array, we are just creating a copy and returning it. So if we want to do it in the O1 time complexity without creating any array space, then we can obviously do it via the by modifying the array supplied argument only. So let us see how this is done. Okay, so here are we with another approach with O1 space complexity, and how we are going to do is again really very simple. So far we have discussed so many approaches, and this one is also going to be a really simple one. The part is that I have a for loop for let I equals to 0, I less than arr dot length I plus plus, and we are having a value over here. So const value equals to arr of I. So this is the array item value, and I am checking that if array dot is array value, if this is an array, then do something, otherwise do something else. And this is where we are going to play with the code. So if it is an array item, then all we need to do is we need to do a splice operation. Okay, so let us go to splice in JavaScript. And if we are again not aware, that splice method changes the contents of an array by removing or replacing existing elements or adding a new elements in place. So if I just say once.splice 10 and feb, it means that at the index 1 remove 0 items and add a feb. So it would go to 0 1, it would not remove March, instead add a feb over here, and the output would be like Jan, Feb and March. If I just say that, okay, at index number 2, or we can say that at index 1 remove 1 item and add a feb. So this would be like Jan, Feb, April and June. Okay, March was removed, and this all happened in the original array only. So it is mutating the original array. All right, so you can see that we are logging out the months array. So okay, we have to make sure that whatever operation we are performing, that mutates the array, because that is how we are going to achieve the O1 space complexity. So talking about this again, so month.splice 1 Feb, it removes March and adds Feb over here. So this is the index where we want to make insertion or deletion, and this is whether how many elements you want to remove and which element you want to add. So on the same notes only, if I just say that array dot splice at index I, remove one item, and what we have to add, okay, and we have to make sure that in the this part, in the last part, you can see that you can pass n number of items as an array. Okay, how many elements? If you, even if I have passed Feb, or again July, okay, so it would be able to add two values at the same time. Okay, so there is no limit to how many values we can add. So we are going to kind of leverage that, and this is a place where we are going to spread out the value by one level. Okay, and we are not updating the ith index. So we are saying that at the ith index, if this is an array, so remove that array, instead flatten that array by one level and insert those elements out of the flattening in the same array index only. Okay, we are saying that at the array I, remove one and spread out the value, and whatever item you are finding is that you just push those elements at the ith index only. So what is happening at ith index? At ith index, we are removing that array item and we are spreading it out. We are flattening it by one level, and whatever is the value, we are just putting it back again at the same index. Okay, this is what we are doing. So at this point, we are flattening and maintaining the index. So we are not going to update the value of I over here, because we again want to check that, okay, after flattening, we might encounter an array again. So we are going to check for the same index again. Okay, if the element is not an array, then only it makes to update the ith value. So we can clear the logs and see if it is working. And yeah, obviously I haven't returned the array, so you can see that at this part. And okay, so and it didn't work, surprisingly. So what mistake have we done? Actually, we have incremented I at the for loop only, and that is why it was not working. We are going to just leave it as it is, and let us clear the console. And yeah, it is working fine. So it is very important that when you increment the ith index, you can't just increment the value of I at the first place. All right, so this was the flatten function in the O1 space complexity. And yeah, this was all in this lecture, and definitely you got to learn a lot of things in a single question. We surprisingly use 1, 2, 3, 4, 5, 6, 7 array utility methods in a single question, and this is pretty much huge. This is huge thing. Okay, and how many approaches did we cover? The first one was array.flat method. Then we had the iterative one. This was the second. The third, we had the improved iterative approach. The fourth was the recursive approach via reduce. And the fifth was the space O1 space complexity approach. These were the 5 approaches to develop the flatten function. Hope you understood everything. If you have any doubts, then please reach out to me on the Discord. And yeah, this was all in this particular lecture. See you in the next one.